All right, in this example, we're going to use an inverse numerically to do some sort of a composition of functions. So with this problem, I need to start on the inside. So I'll grab my pencil here. So I'm going to start at g of 10, and this should have an extra parenthesis. So this is g of 10. That means if 10 goes into g, we want to know what comes out. So if 10 goes into g, negative 1 comes out. So what I can do then is I can rewrite this as negative 1. Or in other words, now my question is to find f inverse at negative 1. Now, instead of finding the inverse of f, another way to look at this is we are looking for the ordered pair. If it's f inverse, it looks like negative 1 what? But if we reverse it to the function itself, then it would look like what input would give me negative 1 as an output. Because if negative 1 is the input of the inverse, then it must be the output of the function. So I can look now at f and see that when negative 1 is the output, the input must be 2. So in other words, if 2 goes into the regular function, negative 1 goes out. Or if negative 1 goes into the inverse, then 2 will come out. So 2 is my answer. All right, next we'll find an inverse algebraically at a number without actually finding the full inverse. So it says here, it says find the inverse, g inverse at 7, without finding the whole inverse, without finding g inverse of x. So what I'm looking for, g inverse means of 7 means I'm looking for if 7 is the input of the inverse, what's the output? So what I can do then is I look at g, okay, the regular function, which means you swap x and y. So g would say what's the inverse, or excuse me, what is the input if 7 is then the output? So if in the inverse 7 is the input, then in the regular function 7 must be the output. So what I have is g. So I want to know when 7 is the output, what must x have been? So in other words, I want 7 to equal 4x minus 1. So I'm going to solve this. So I add 1 to both sides. 8 is 4x. So x must be 2. So coming back up here again, we can say that if 7 goes into the inverse, then 2 will come out, which is the same as saying if 2 goes into the function, right, 4 times 2 is 8 minus 1, then 7 will go out. So both of these are true statements. So the answer is, when it says find g inverse of 7, then g inverse of 7 is 2. All right, lastly, we'll look at a graph and find g at f inverse at 3. So with this problem, I'm going to start at the inside here. So I need to find f inverse at 3 on my graph. So without having to find the entire inverse of the graph, what this means is I am looking in the inverse. If 3 goes in, what comes out? So if I want to look at the regular function, then what would have to go in for 3 to come out? So I'm looking at the x value of f when 3 comes out. So here's my f. So if 3 comes out, if 3 my y value, then 1. 1 is my input. So 1 would be my input. So in other words, this says if 1 goes in, 3 goes out. So that's the same as saying in the inverse, if 3 goes in, then 1 goes out. So this is 1. So now I'm to the point where I have g at 1, which now I can just look directly at the red graph and say, if I go to the right 1, then the output would be negative 5. So g at 1 is negative 5. So in other words, g of f inverse of 3 is negative 5. So this is my answer.